Okay, so now we're on to day 2 of Unit 4. So yesterday we talked about just triangles in general. Today we're going to focus on properties of isosceles and equilateral triangles. First up is isosceles. On an isosceles triangle, the congruent sides are called the legs of the triangle. And a way to remember that, you walk on two legs. The congruent sides of an isosceles triangle, there's two of them. So two legs, just like you walk on two legs. The vertex angle is the angle formed by the legs. So I guess we should be labeling this picture as we go. So the legs are the two congruent sides. That's a leg. That's a leg. Angle 3 down here is our vertex angle. It's the one that connects the two legs. The side opposite of the vertex angle, so all the way across, is called the base. So this is our base. And the base angles are the two angles on the ends of the base. So these two angles are considered base angles. So we're actually kind of ahead of ourselves. It says to label it. Well, we labeled it. Angle 3 is your vertex. Angles 1 and 2. Not only are they congruent, but there are base angles. Then we've got our legs and our base labeled. So it's important to note here. I just mentioned it, but angle 1 is congruent to angle 2. So we know the legs are congruent. That means the base angles are also congruent. Okay, so let's look at some theorems that involve isosceles triangles. So if the two sides of a triangle are congruent, then two angles of the triangle are congruent. So we're told that AB is congruent to AC. That means B has to be congruent to C. So angle B is congruent to angle C. Similarly, we can take the converse of that. If two angles of a triangle are congruent, then that means two sides are congruent. Here we have E and F congruent. So that means segment DE has to be congruent to segment DF. These two must be congruent. Okay, so let's take this and work a couple of examples here. So they ask us to find the measure of angle C. Well, what do we know this? We know this. These two sides right here are congruent, which means this is our base. So the base angles have to be the same, which means this one is also X degrees. So if we think back to yesterday, you'll remember hopefully that all the angles in the triangle add up to 180. So to find our x, we have to add up all of our angles and equal them to 180. So x plus 38 equals 180. This gives us 2x right here. So 2x plus 38 equals 180. Subtract 38. You'll get 2x equals 142. Divide by 2, and x equals 78. No. 71. Where did I get 78 from? No clue. 71. Okay. So they ask us to find the measure of angle C. Luckily, C is just x right here. So C is just x. So we can conclude that measure of angle C equals 71 degrees. Okay, let's look at B. Again, we're told that these two legs are congruent, which means these two angles must be congruent. R and S must equal each other. And they ask us in particular to find angle S. Well, if they're equal, to find S, or to find X first, let's just set 2x equal to x plus 30. Subtract x. We get x equals 30. Now, do they ask us to stop there? No, they ask us what S is. So the measure of angle S equals 2 times 30, which is 60 degrees. Okay, so that's our first two examples. Now let's flip to the back and look at equilateral and equiangular triangles. So if you have an equilateral triangle, then you have an equiangular triangle. So they tell us all the sides are the same, so that means all of our angles are the same. Angle A is congruent to angle B, which is congruent to angle C. And they all equal 60 degrees. We could also take the converse of that. If you have an equiangular triangle, then you have an equilateral triangle. So remember, equiangular means they're all 60 degrees. So they tell us that angles D, E, and F all are 60. So that means all of our sides must be equal. DE must be congruent to EF, which must be congruent to FD. Okay, so they ask us to find the value of x. Well, we're told here that this is an equilateral triangle, which means it's also equiangular. So all angles have to be 60. So how can I solve for x? Well, I know C is 60. So just say 3x plus 15 equals 60. Subtract 15. We get 3x equals 45. Divide by 3. And we get x equals 15. Okay, on to the next one. So for this one, they tell us it's equiangular. Well, if it's equiangular, that means all the sides also have to be the same. So to get t, I'll simply set the sides equal to each other. 4t minus 8 equals 2t plus 1. Subtract 2t from each side. I get 2t minus 8 equals 1. Add 8 to both sides. I'll get 2t equals 9. Divide by 2, and I get t equals 9/2, which is also 4.5. And it just asked me to find t, so I'm done. Okay, the next two problems, actually it's just one problem. The next one problem is a review. So we're asked to find the measure of angle A. Well, what do we know? This is on the inside of the triangle. This is our exterior. These two angles would be considered our remote angles because they're the furthest away from our exterior angle. So what do we know about two remote angles and the exterior? They're equal. Well, you add them and they're equal. Sorry. You add them and they're equal. The two interior equal that exterior. So 10x minus 5 plus 8x plus 3 equals 124. So I'm going to combine my x's. 10x plus 8x gives you 18x. Negative 5 plus 3 gives you minus 2 equals 124. Add 2. Get 18x equals 126. Divide by 18 and you get x equals 7. But that's not all they ask us to find. They ask us to find the measure of angle A. So that means we have to plug it in. So 10 times 7 minus 5 equals 65 degrees. There you go. Okay, so for the notes, that was it. It's fairly short on notes today. So stay tuned for the guided practice.